Now, we have our idle mass flow feed forward main table. This table here is set up on coolant temperature versus idle aim. What I'm going to do here is get rid of the coolant temperature for right now and just do based on idle aim. Let's go here and we're going to expand this out and make it a pretty large two-dimensional table. Now we can introduce coolant temperature at another point in time, but what we'll find in general is that we can set this up typically just on this 2D axis on idle aim. Idle aim is where we want to idle at, which is coming from our idle aim main in any modifiers. We're going to break all this down in the idle control tuning tutorial to get that sorted out, but we want to go and set this table up. Let's go here to clear table, and we're going to go in here and do a generate option. And we're going to go here from, let's say something low like 700 RPM, and let's go up to something like 2000 RPM, and let's move in something like a 100 RPM increment. Now, we don't have enough available breakpoint sites here, so I'm going to go ahead and maybe do it to something like 1600. We'll try even 1700. Okay, let's click OK here. So now we can see what this table looks like. This is going to call out where we want the throttle blade to park itself at in the 0 to 10% range. So this is a 0 to 100% scale of the 0 to 10 that we've set here for the maximum. So what we'll do here is just put it at a value at something that will probably make sense to kind of get things going. Let's park our throttle at something like 50% across all of the values, and we'll talk about how to set this up in another tutorial doing the idle control tuning in the open loop format. Then we'll turn on closed loop and make sure it works. There's an idle mass flow disabled table here. This table is not applicable when we're talking about drive-by-wire. It is not used, so we'll make sure we just turn this off for right now. Click OK, and we'll just turn our value here to, well, we can keep it at the default. It's ignored anyway. We'll just keep that at 80. Okay, now let's keep moving on here and making sure we've covered all of the other tables that we need to account for. So boost setup. We do not have boost control naturally aspirated. We're not doing anything with the boost setup or the boost PID. Knock tuning we are going to be using. Now let's go in and configure this. We first want to go in and set this up so that it's going to ignore the knock threshold or try to raise the knock threshold up so that the knock control is not going to be active and doing anything, because we actually need to calibrate and set the knock threshold table up, but we also need to make sure the frequency is accurate for the engine we're calibrating. And we're going to talk about how to do all of that in another training module. We will be relying on the knock control heavily to calibrate and tune our spark timing. I'm going to go to the knock threshold table here. We can see the table here is based on fuel composition percent, and it's based on engine speed. If we click A here, we could also base this on engine load normalized. What I'm going to do is turn off fuel composition for right now and base this on the engine load normalized. We'll go to generate, and recall that engine load normalized is our map pressure. So 0, let's say 100 kPa. Let's move in 20 kPa increments. Click OK. Click OK. And now the table here is going to be just changed up a little bit. So we have engine load normalized on our left axis. Top axis is engine speed. I'm going to go and set this to a value of 100. We're raising our threshold up to get it out of the way so that we can calibrate our airflow model and then calibrate our knock control with no knock, and then we can start to dial in the knock threshold. So we can't do anything with this, so we're just raising up to the maximum values to get it out of the way to hopefully make sure that everything is going to be we can dial everything in without having to worry about the knock control being active. Now the next thing here is we have a knock ignition trim limit. This is based on fuel composition versus engine speed. If we click A here, let's turn off composition for right now, and I'm going to go in here and just zero the table out. Now it's not going to let me go any lower than 0.1. This is going to be calling out the maximum spark retard that the knock control can command. 0.1's fine. That's going to essentially bypass it for right now. Again, we're looking to dial in our airflow model, then look at our knock control, set all that up, activate it, put a proper knock limit threshold here for the retard amount, how much it can actually take out as a maximum, and then we can use that for dialing in our spark timing. Now there is going to be a recovery rate. There is a knock window width. We'll keep that at 60. Activation delay here, 10 milliseconds. And then the knock trim gain, we typically leave this at 100. We also have our mode here. This is going to be looking at all of the different options we have for programming the frequencies, and we're not going to do anything with that right now. Window, we do want to start it here about 10 degrees ATDC. All the rest of this looks good. So we also want to make sure the knock gains are all set to 100% per volt to make sure that all the cylinders are even when we start to look at it. We don't want these set anything else beside 100 for right now. Okay, so this all looks good in here. We've essentially armed the knock control in sense where it's actually activated, but it's not doing anything. Shouldn't do anything. Inlet cam. Okay, so here's going to be our variable cam timing. We're going to go here and change a few things up. First things first
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.